Hello students, welcome to the IMS Gate Academy. How are you all? So hoping that all of you are good, and please anyone please confirm whether audio video both are clear or not. I'm waiting for your response. Please do respond so that we are good to go with the session. Okay, all right. So I hope that you might have already known about this particular session, which is a foundation course, and as you all know that in this foundation course I had already taken the total of 6 lecture of the electrical machine, and those particular thing was quite responsive. Okay, so whatever response I have got from your side, it was wonderful. All right. So this is going to be the lecture number 7 in the foundation course, and meanwhile I'll give some time to you to share the session link with your friends so that they can also come up here to join as a live, so that we will going to have a good session over here. And also please do not forget to mark your attendance by hitting the like button. It is important for all of us. All right. So guys, this foundation course is basically meant for you, because from here we are going to build up your basics. As you already know that the electrical machine is one of the challenging subject, because it is having a lot of concept related to the laws as well as to the theory as well as the rules, because this electrical machine is what? Amalgamation of your electromagnetic theory along with the DC machine, or you can say machines plus devices, like that. Okay, so this electrical machine is common for EE and IN, so both stream can join over here. Alright, so guys, please do share the session link with your friend, and do not forget to mark your attendance by hitting the like button. Alright, so let us start today's session. Okay, so this is lecture number 7, types of EMF and dot conversion. Please do confirm audio and video. Alright, so in the last lecture we had discussed about the EMF, and I told you that we are going to have 2 types of EMF, that is statically EMF or the statically induced EMF to be precise, and the another one dynamically induced EMF or motional EMF. So what is statically induced EMF? When the rotor or conductor is stationary and magnetic field is rotating, then in that conductor the EMF is going to be induced. Since rotor is stationary, therefore it is static, and the EMF that it is going to be induced is known as statically induced EMF. And all of us know that in the transformer we are not having any moving part. So in the transformer, whatever EMF is inducing in the coil, basically primary coil and the secondary coil are known as statically induced EMF. Okay, so look at here. According to Faraday's laws, we know that EMF is equal to N d phi by dt. So this is according to Faraday's laws. All right. So this will going to give you a magnitude, but this is not 100% correct, because it will give you only magnitude but not the polarity. So the polarity is given by the Lenz law, which is minus n, like in this expression put minus sign. So it will be minus n d phi by dt. So this is according to Lenz law. Alright, I hope this is clear. So what is N? N is the total number of turns in a coil. What is phi? Phi is the flux. Phi is the flux. Okay, so this phi or the flux is what? Depends on time, or it is time varying flux. So since it is time varying flux, so therefore with respect to the time it will going to have an EMF in the coil. So this will give you statically induced EMF. Got the point? So here means where phi is phi m sin omega t, or unit is Weber. So see, this is what? Sinusoidal, or with respect to time it is changing, the flux is changing. So since it is this flux is depends on the time, therefore EMF you are going to have, or you are going to have in the coil. Okay. So basically, suppose if you have a coil like this, just a second, suppose if you have a okay, so let me take an example over here. Suppose you have a coil like this, okay, and this is connected with some voltage source. So which is, let me take V of t equal to Vm sin omega t. So since this is a coil and you are having the voltage source which is alternating in nature, definitely whatever current will come, that will also be a sinusoidal in nature, assuming that no harmonic is present over here. So I of t is also sinusoidal in nature. So since this current, what it will going to do? It will going to link to this coil, and therefore MMF is going to be produced, and from there and from that MMF, what is MMF? N into I, number of turns of a coil, current flowing through the coil, it will going to produce a MMF. So from that MMF, flux is going to be produced, and since this current is sinusoidal in nature, therefore MMF is sinusoidal in nature, therefore flux is also going to be sinusoidal in nature, and you are going to have an EMF. Okay. So such type of EMF is known as statically induced EMF. I hope you have got the concept. Okay. Let us move ahead to the one particular example. Look at here. Determine the induced voltage at the terminal AB for the given circuit where phi equal to 10 sin 314 t milliweber and number of turns n equal to 100. So here you are having total number of turns as 100. This is the flux. So we need to find what? We need to find the induced EMF. So EAB we need to find. Let me take EAB, I need to find. So this is equal to minus n d phi by dt, minus n d phi by dt. So what you need to do? Substitute n value here, which is 100 into d by dt. So what is phi value? Phi is 10 sin 314 t. Okay, all right. But this is milliweber, na? So into 10 to the power minus 3. All right. So this amount of EMF is going to be induced over here. तो चलो simplify कर लेते हैं. So minus 100 into, so it will be 10, then cos 314 t into 314, इसका derivative into 10 to the power minus 3 because of milliweber. जरा simplify करो. So it will be 10 to the power 3, 10 to the power minus 3 will be cancelled out. So it is minus 314 cos 314 t. Okay, what else we can write? We can write 314 sin 314 t minus pi by 2. Are yes or no? Yes or no? So from here I can say that your EMF EAB, so this amount of EMF you are going to have here. Okay, in this coil, this amount of EMF is going to be have 314 sin 314 t minus pi by 2. volt. Okay, so this EMF or this coil will have this amount of EMF. Now, if you see carefully, taking flux to be reference, your EMF will going to lag by an angle of 90 degree, and this is true for the transformer or for any machine. ठीक है? So please do remember, it is very important point. It is very important point because like see, whenever your flux is going to be happen, just after 90 degree, your EMF is going to be induced in this coil. ठीक है? So मेरे कहने का मतलब क्या है? Let me add a page. Okay, just a second. Okay. Assume this axis as omega t. This is your flux, which is phi m sin omega t, and this axis is your EMF. Okay. So if your flux is sinusoidal in nature, like this, so this is pi, and this is 2 pi, and this will be your pi by 2. Okay, so this is pi by 2, and this one is 3 pi by 2. So we know that EMF is going to be lag by an angle of 90 degrees. So it will start from here. Like this it will come. समझ में आ गया? So after 90 degree your EMF is going to start. Okay, all right. So let us move ahead with the next EMF that is dynamically induced EMF, or also known as motional EMF. So what do you mean by motional EMF? What do you mean by motional EMF? Unlike statically induced EMF, where the rotor was stationary, here we will make the rotor or conductor to be in motion, and with respect to that motion your EMF is going to be produced. Am I clear? देखो क्या होगा. So this is your magnetic field plane. Cross means magnetic field is inside. Okay, magnetic field is inside. So what I will do, I will going to assume one conductor over here. So suppose this is a conductor, okay, and this conductor is moving, let me take in this direction, okay. Is this color visible to you? Okay, so it is moving in the right direction with a velocity v, and magnetic field is inside. So for the case of simplicity, let me take the XYZ plane. So this is X, Y and Z. Now see here, this is your conductor, and this conductor is moving in a magnetic field. So we know that all the conductor, in that we are going to have the charges. Because of that only the current will going to be flow, na? So you are going to have a charges over here. So that charges will be your positive and negative as well. Now, as soon as your conductor is moving, in the same way your charge is going to be moving inside this inductor. समझ में आ गया मैंने क्या बोला? ये कंडक्टर जैसे ही मूव कर रहा है उसके अंदर में जो भी चार्जेस होगा वो उसी के साथ फ्लो करेगा. Am I clear? Now we know that from the Lorentz force equation, whenever conductor is moving in a magnetic field, it will going to experience a force. Am I clear? It will going to experience a force. तो इस force का equation क्या होता है? What is force equation? According to Lorentz law, it will be F equal to Q V, that is velocity, into B. Any doubt? Clear? Now, my friend, let us simplify velocity and magnetic field in terms of magnitude and direction. Okay, कैसे होगा देखो, velocity v or vector, its magnitude will be v, but it is flowing in which direction? Y direction. So it will be ay cap. Done. Now what about magnetic field? Magnitude will be b and magnetic field is inside. So see, x is outside means we have taken positive, inside means x will be negative. So it will be minus ax cap. Am I clear? Am I clear? Any doubt in this? Okay. Okay. All right. One more thing. One more concept is required. Ax into ay. It will give you Az. Just a basics of your electromagnet. Ay into Az will be Ax. Az into Ax will be Ay. And if you rotate in anti-clockwise direction like Ax into Az, it will be minus Ay. Okay? So this basics is required. Now look at here. As I told you, you are going to have this kind of force. But this force depends on the charge. See, this charge can be positive or this charge can be negative. So depending on this Q, you are going to have the force. So देखें यहाँ पे, I am going from very basic so that each and every one of you can understand this particular topic very effectively. बहुत important है, नहीं समझ में आएगा please do let me know. I will explain you one more time, but doubt अपने पास नहीं रखेंगे. All right. Now, first, if charge is positive, then the force will be, given as, okay, so look at here, for the positive charge, let me write F force, F plus, which is equal to Q. Okay, all right, Q. V का क्या है? V ay cap into magnetic field B into minus ax cap. Okay, so I can write this as V or Q, that is positive charge, V into B. So this is magnitude and ay cap into minus ax cap. Okay, now I can write this thing like this, minus of ay cap into ax cap. मैंने नेगेटिव साइन को यहां पे ले लिया है. Now look at here, ay into ax कहां गया? ay, आपको ay से ax जाना है, means you are moving in anti-clockwise direction, so negative will come. So ay into ax will be minus az, है कि नहीं? यहां से भी देख लो, आपको ay से ax जाना है, So means you need to move from this to this side. तो कैसे होगा? ay to ax. So means it will be inside, or basically not inside, downward. So minus az. So it will be minus az. Okay. VB into minus AZ. This is minus AZ and you are having one more negative sign. So let me write plus AZ cap. क्या ये समझ में आ गया? This thing will give you minus AZ, then this negative will make it plus. Any doubt? Now in the same manner, B. Okay, just a second. If the charge is negative, then the force is given by. See here, for the negative charge, the force will be, let me write F negative. Okay, F minus. So this is equal to minus Q, that is negative charge. Now V is V into AY cap cross B into minus AX cap. All right. So देखो क्या होगा, this minus and minus will become plus. So it will be Q V B AY cap into AX cap. Okay, AY into AX is what? Minus AZ. So it will be minus, or let me write V Q V B into minus AZ cap. क्या ये clear है? Is this concept clear? Now what we have understood from this concept? Okay. So let me go back. Look at here. What this expression implies? It implies that this expression implies that the magnetic field force the positive charge in this conductor to be shift in plus z direction, means upward, है ना, positive az. तो कहने का मतलब ये है, it will shift the positive charge here. Magnetic field, isn't it? Now what about negative charge? Minus az. Minus az means which direction? Downward direction. So negative charge will appear here. Or to be precise, let me take this end as P, this end as Q. Okay, it means that at P your positive charge is going to be accumulate, and at Q or bottom you can say negative charge is going to be accumulate. So the magnetic field pushes the charge, positive charge to be upward and negative charge to be downward. Am I clear? Now if you have if you know the concept of electric field, like when the electric field is going to be generated, for that the condition is you must require positive charge on one side and negative charge on another side. That is what you have. Here you are having positive charge and here you are having negative charge. So therefore it will going to create one electric field. So it will going to create an electric field from positive to negative, because electric field flow from positive to negative. Let me change the color. Okay, whether this color is visible to you? Okay. So this is the direction of your electric field. This is the direction of your electric field. Any doubt till this point? ये कलर विजिबल है क्या? ओके ठीक है, चलो मैं एक बार चेंज कर दे रहा हूं. जस्ट अ सेकेंड, लेट मी चेंज द कलर. दिस इज इलेक्ट्रिक फील्ड. ओके, ये इलेक्ट्रिक फील्ड का डायरेक्शन है. डन. ऑल राइट. नाउ दिस इलेक्ट्रिक फील्ड is again going to produce, or basically it will going to insert a force. It will going to exert, not insert, it will going to exert a force. Why, sir? Because we know the relation F. See, electric field is also going to exert a force on a charge. Why, sir? Because we know the relation F is equal to QE. ये जानते हो कि नहीं? Force per unit charge is nothing but your electric field. So this amount of force, it will going to be exert over the charge by the electric field. Now if you see, if Q is positive, let me change the color. If Q is positive, then F is in parallel with E. F is in parallel with E. What do you mean by this? Means in the same direction where force is going to be act, whatever the direction of electric field you are going to having. ठीक है, दोनों की डायरेक्शन क्या होगी? सेम होगी if Q is positive. Okay. Next, what if Q is negative? Means if the charge is negative. If Q is negative, then force direction will be anti-parallel to electric field. मतलब if electric field is in right, then force will act in left direction. ये फर्स्ट पॉइंट क्या बता रहा है? अगर इलेक्ट्रिक फील्ड राइट में है तो फोर्स भी राइट में होगा, या इलेक्ट्रिक फील्ड अगर लेफ्ट में है देन फोर्स भी क्या होगा? लेफ्ट में होगा. लाइक दैट. तो यहां से वी कम टू नो दैट, सॉरी, फ्रॉम हियर वी कम टू नो दैट this electric field is going to exert one more force, and that force due to electric field, what it will going to do? It will going to make, let me change the color here. Okay, what it will going to do? It will going to make the positive charge to be shift in downward direction, because electric field की direction क्या है? Downward. So positive charge, it will try to force the positive charge to shift to down direction. Am I clear? And your negative charge, electric field tries to force in upward direction, because opposite direction में act करेंगे electric field and force because of negative charge. So negative charge will try to accumulate over here. ठीक है? Now under equilibrium condition, condition क्या होगा? नेट फोर्स ऑन अ चार्ज F net, it will be 0. है कि नहीं? जैसे एक जो है राइट हैंड साइड में हम लोग खींच रहे हैं, दूसरे को हम लोग मतलब द लाइक द सेम थिंग, हम क्या कर रहे हैं, इसको राइट हैंड साइड में खींच रहे हैं विद द सेम फोर्स, तो क्या ये पर्टिकुलर थिंग मूव होगा? सपोज आपके पास एक रबर बैंड है, सो इट विल गोइंग टू हैव टू एंड्स, सो विद द सेम फोर्स वी आर ट्राइंग टू मूव one portion of the rubber to the right hand side and one portion of the rubber to the left hand side with the same amount of force. Whether it will going to be move? No, it will going to be stay as the center. I am not talking about the stretchable part. Okay, the movement, the net movement of the rubber. So the net force it will going to have as a 0. Now what is net force? Net force is produced by the magnetic field and electric field. That is what we have seen. तो क्या था वो? सो फोर्स प्रोड्यूस बाय इलेक्ट्रिक फील्ड प्लस फोर्स प्रोड्यूस बाय मैग्नेटिक फील्ड, इट विल बी 0. तो ये क्या था? क्यू ई प्लस क्यू वी क्रॉस बी, दिस विल बी 0. So see, can I write like this? Taking Q common, it will be E plus V cross B, and this will be 0. Now this Q cannot be 0 because it is a charge, so this can only be 0 when this second term is 0. Okay, since this is a product, so either one of them can be 0, both can be 0, but Q cannot be 0, therefore the inner term is going to be 0. So E plus V cross B, it has to be 0. So I can write like this: E is equal to minus V cross B. All right, this is very important point. Let me inbox this. ठीक है? So this amount of EMF, sorry, the electric field you are going to be have. चलो देखो अब क्या होगा. See, this V cross B, this is acting in Y direction ना. V cross B कहाँ पे था? Let me show you. See, V cross B कहाँ गया? V in this direction and B is downward direction. अरे देख लो ना कहाँ पे था. Sorry, inside ना. ये कहाँ पे था? V cross B. So velocity is in this direction and magnetic field is inside. So V से minus x जाना है. V से minus x. So it will be upward. Upward means your AZ के direction. Upward means AZ के direction. But you are having one negative sign over here. It means downward direction. Electric field की direction फिर क्या हो जाएगी? Minus AZ. That is what we have got. That is what we have got. See, the direction is downward. समझ में आया? So from here also we can find the electric field direction. ठीक है? Now, what will be the EMF that you are going to be have over the conductor? What EMF you are going to be have over this conductor? किसी को वो expression पता है EMF वाला? That how EMF is going to be produced when you are having the electric field? नहीं? So see, देखो यहां पे कैसे होगा. Okay. So V, that is EMF or potential difference or potential gradient, you can say. This is equal to minus integral E dot dl, that is vector product. Sorry, the dot product. Okay, what is dl? dl is the length of the conductor and E is the electric field which is over the conductor, means over the same conductor. तो देखो हमने क्या फाइंड आउट किया है? E minus of V cross B dot dl vector. So this minus minus is what? Become plus, so it will be integral V cross B dot dl. क्या ये समझ में आ गया? एनी डाउट इन दिस? इसी को हम लोग क्या बोलते हैं? EMF. एंड यू माइट हैव स्टडीड, सॉरी, EMF like this, E equal to VBL sin theta. याद है? VBL sin theta. और सिंपली if theta is 90 degree, where theta is what? Angle between V and B. Angle between V and B. If theta is 90 degree, then it will become velocity, magnetic field and length of the conductor. वही चीज हमने अभी derive किया है. That is what we have derived over here. This voltage is nothing but your EMF. So voltage, let me write here, voltage induced in a conductor. ठीक है? What is DL? DL is the length of the conductor and it always directed from negative charge to positive charge. It always directed from negative charge to positive charge. तो यहां पे देखिए, where is negative charge? Negative charge is here. And where is positive charge? Positive charge is here. So it means that in the induced EMF, your plus terminal will be here and negative terminal will be here. I mean to say, how we will going to represent it? So suppose this is your conductor which we had taken. Okay. So this was your P and this was your Q. So this EMF expression will tell you, ये जो expression है, this will tell you that positive polarity will come here and negative polarity will come here. Means P will be positive and Q will be negative. Now other representation of the EMF is what? We can represent, instead of showing positive and negative, we can also use the arrow. And what this arrow sign implies? This arrow sign implies the direction of EMF. Means, or the polarity of EMF. So the direction is always from negative to positive. And you might have seen in some of the standard books. ठीक है? पॉजिटिव नेगेटिव ना लिख के हम लोग इस डायरेक्शन से भी पोलैरिटी को शो कर सकते हैं. ठीक है? प्लीज रिमेंबर, डेल एल इज द लेंथ ऑफ द कंडक्टर विच डायरेक्टेड ऑलवेज फ्रॉम नेगेटिव चार्ज टू पॉजिटिव चार्ज. ठीक है? सो दिस इज ऑल अबाउट द मोशन EMF or dynamically induced EMF. I hope you have got the concept related to the EMF. Now let us discuss one more important concept that is very, very useful in the transformer. Okay, which is dot convention. So what do you mean by dot convention and why we are using it? Why we are using this? Dot conventional is basically, it help us to identify that which terminal of a coil is positive or basically either positive or negative. Which terminal of a coil is either positive or negative, provided in another coil the polarity is given to us. मुझे पता है मे भी समझ में ना आया होगा, मैं एक्सप्लेन कर रहा हूं, ध्यान से यहां पे देखिएगा. ओके, So let me take here one example. Suppose this is your iron piece. This is your iron piece. In this iron piece, you are going to have two coils. One coil is like this. Let me name it as P and Q. And another coil is like this. Let me name it as X and Y. Done. Now, as I told you that you are going to find out the polarities, plus and minus. Therefore, you are going to have an EMF. So, this dot convention is basically, it will going to be a help when you are going to have the mutual induction. What do you mean by mutual what do you mean by mutual induction? Suppose in one coil, if a voltage or a source is given to us, then the flux is going to be produced in one coil, then that particular flux is going to induce an EMF in the another coil as well. That is nothing but the mutual EMF or mutual flux you can say. ठीक है, मैंने ये बोला कि this is one coil and this is another coil. तो इस coil में अगर कोई flux है, then that flux can induce an EMF in another coil as well. And if we know the polarity of P and Q, अगर ये दिया गया होगा, then we can easily determine the polarity of X and Y, which is nothing but the basic principle working or you can say the working principle of the transformer. ठीक है, तो देखो कैसे होगा. So let me take a current here as I or I1. This is I1 current. Now this I1 current, what it will going to do? It will going to flow through the coil, and we know that whenever a alternating current, this I1 is alternating current, whenever alternating current is flowing through the coil, a flux is going to be generated and its direction is given by Fleming right hand palm rule. तो देखो कैसे होगा? It is upward, है ना? Current direction is upward, so flux direction will be from right to left. So this will give the the flux in this direction. Okay, so this is the flux of a coil 1. Now, so this flux is going to be induced an EMF in the second coil. Okay, so the flux or basically the nature of the flux can be two types. Either flux produced by both the coils can be adding in nature, or it can be repulsive in nature or opposite in nature. So let me take a general example of transformer where the fluxes are opposite to each other. So यहाँ पे देखिए इस coil का flux इस side है towards left hand side. तो इसको oppose करने के लिए what should be the flux direction of the second coil? It will be towards right. Are yes or no? It will be towards right. Okay. So this is your flux direction. Of the second coil. Now my dear friend, what should be the current which is flowing in the second coil such that it will going to produce flux in this direction? तो कैसा होगा? Again we are going to use the Fleming right hand palm rule. देखो flux के direction इस side है of the second coil. Then the current direction is what? From back side it is upward and from front side it is downward. So its direction will be, from front side it is downward and from back side it will be upward. See the wounding nature. So from this y is what? From back side, and this x is from front side. So ये रहा direction. Let me write this as I2. So here I have taken a case of opposing flux. Opposing flux. Okay. Now see, as we know that since this is given to me, definitely I know the polarity of P and Q. यहाँ पे देखो करंट यहाँ से डिलीवर हो रहा है ना, so this is plus and this is minus. This is plus and this is minus. Done. So either you can put a dot in plus or in minus. Only at one point we need to place a dot. Let me take, I am placing a dot at positive side. So this positive side will tell me that this is your, this dot will tell me that it is positive. क्योंकि ये तो पता है ना, this is given to me. This is given to me. Now we need to determine here like whether which terminal is positive and negative. So please do remember that if in one terminal wherever the current is entering, the dot is going to be placed, and in the second coil where the current wherever the current is leaving, we need to place a dot. So dot यहाँ पे आएगा क्योंकि यहाँ पे करंट लीव कर रहा है. एम आई क्लियर? मैंने क्या बोला? फर्स्ट कॉइल में करंट एंटर कर रहा है, वहां पे डॉट होगा. तो सेकेंड कॉइल में जहां पे करंट लीव करेगा, दैट विल बिकम द डॉट. एम आई क्लियर? नाउ माय डियर फ्रेंड, वी नो दैट in the first coil dot we have represented as positive. It means that here this dot will be positive and here the other terminal will become automatically negative. क्या ये समझ में आया? Any doubt in this? क्या ये clear है? ठीक? Now second case. Adding flux. So let me take this as A, B, here, C and D. So this is your current direction in the first coil. Sorry. Okay, so what will be the direction of flux in this case? It will be towards left hand side. है कि नहीं? Fleming right hand palm rule. Now, adding flux means what? The flux produced by the second coil. This is coil A and this is coil B. Okay, one more thing. Here we have determined, na? Just a second. This we have determined. Okay. Okay, ये मुझे दिया गया था और यहाँ पे हमने find out किया है. Okay, all right. So come to this question. Here this I1 is basically going to give you flux in this direction towards left hand side. So adding flux means what? The flux produced by the second coil, it should act in the same direction, means towards right hand side, towards left hand side. तभी तो आप एडिंग बोलोगे ना, यहाँ पे दोनों अपोजिट डायरेक्शन में से, सो अपोजिंग, हियर बोथ आर इन सेम डायरेक्शन, सो एडिंग. अब देखो यहाँ पे क्या होगा, व्हाट शुड बी द डायरेक्शन इन द सेकेंड कॉइल, मीन्स द डायरेक्शन ऑफ करंट इन द सेकेंड कॉइल सच दैट इट विल गोइंग टू प्रोड्यूस द फ्लक्स इन लेफ्ट डायरेक्शन. तो कैसे होगा, फ्लक्स, दिस फोर्थ फिंगर विल गिव यू द डायरेक्शन ऑफ करंट. So from front side it is upward and from back side it is downward. So देखो कैसे होगा. So from front side it is upward. Let me write here I2. And from back side it is downward. So it will be I2 here. Okay. Now, as I told you that in one of the terminal where the current is entering, means basically in the first coil, where the current is entering, we will going to place a dot. And in the second coil where the current is leaving, we need to place a dot. So it means that it is positive. A is positive, then automatically B will be negative. So according to the dot convention, the dots will going to have the same polarity. So dot को हमने positive लिखा है, तो in the second coil, dot is going to have positive sign. Clear है? Any doubt in this? Okay. So let us come to the homework part. Let me make a coil. This is P, Q, I1 current. This is X and Y. Okay. So this is for opposing flux. This is homework question na? Homework question first. Okay. Homework question first. Let me take the second case. A, B, and here C and D. This is your current direction I1, and take the case of, again let us check whether we are getting same or different. Adding flux. This is homework question number 2. Homework question number 2. Okay, so what you need to be find out over here, the polarity of X in the first question and polarity of the D in the second question. So once this session is going to be over, please do comment in the please do answer in the comment box. Okay, so whenever I'll have a time, I will go through all the answer that is given by you. Okay, तो यहाँ पे मुझे क्या बताना, मतलब आपको क्या बताना है, X की पोलैरिटी क्या होगा, प्लस या माइनस, एंड D की पोलैरिटी प्लस या माइनस. ओके, just a second. One more homework question, just let me make the figure. A, B, and this is current I1. And this is C and D. Okay. So this is given to me, AB is given to me, and I need to find the polarity of C and D. So this is a homework question number 3rd. Okay, so you need to find the polarity of C in the 3rd question. तो आप इस तरीके से कमेंट करेंगे, 1 का X का पॉजिटिव मीन्स फर्स्ट होमवर्क क्वेश्चन X पोलैरिटी और द टर्मिनल, और वो टर्मिनल पॉजिटिव है या नेगेटिव. सिमिलरली 3rd क्वेश्चन C पॉजिटिव या नेगेटिव जो भी आ रहा होगा. इन 3rd क्वेश्चन अगेन C पॉजिटिव और नेगेटिव. ओके, लेट मी गिव यू द हिंट. Working principle of transformer. Working principle of transformer. All right. Come to the next question, which is the last one. Okay. So let me take P, Q, C and D for opposing flux. So let me give the current direction. It means that Q is positive because from here the current is entering into the coil, na? So Q is positive, that we know. So you need to find the D polarity. You need to find the D polarity for the homework question number 4. So total you have 4 questions. So please do practice all these things. Definitely you will have the good command over the dot convention along with the motional EMF and statically induced EMF. All right. So with this we have completed the lecture 7. I hope you have enjoyed, and definitely if you are having any doubt, please do post your doubt over the comment box. I will going to clarify all the doubts, whatever your doubts, you will going to be post in the comment box. Okay. So I hope you have liked the session. You have enjoyed the session. So if is it a case, then please do hit the like button. It is very important for us. And also please do share the session link with your friend and colleagues so that they also going to get benefited from this particular session. And if you have not yet subscribed to our YouTube channel, please do subscribe it, because it is very important for you as like whatever session that we are conducting, it is only meant for you. So in the near future we are going to come up with more initiative. So if you want to get the maximum advantage, or if you want to have the best out of this particular session, then you need to subscribe our YouTube channel. And at the same time, please do not forget to press the bell icon, because I want you to be the first one to get notified for all of the session that we are conducting over here. All right. So we'll see you again in the next lecture, that is going to be held on happen on tomorrow. The timing will be 6 to 7 for the tomorrow's session, and that will be lecture number 8, and we will discuss in that per unit. It is very important not only for the electrical machine perspective, it is also with respect to power system, analog, and so on and so forth. Okay. So let me give you one homework question again, like why we are using the per unit, why we are using the per unit concept. All right. So let me end the session over here. Bye bye, and take a very good care of your health.